Hello everyone, this is Samir once again. Today I'll be introducing to you Xtrudy, a new small plugin for Cinema 4D. But let's take a look at the actual problem that Xtrudy is about to solve. Let's create an extrude object, a native extrude object in Cinema 4D, and maybe use an air rectangle, just a simple shape to show you the problem. I'm in groove shading lines mode, so I can see the triangulation of the extrude object. And let's just switch here to uniform. And of course the n-gons will not be shown, but if I change it to triangles, I can see the actual triangulation of the extrude object also by the n-gons. And we can see, well, this doesn't look very well, or even if I change to quadrangles, we can see it doesn't get better. So if I wanted to, well, deform this, I need more polygons. So I use the regular grid, and we can see the problem right here. We have a regular grid, well, in the inside, and it doesn't matter what the width is here. We still get these, well, long stretch polygons. So it actually gets worse the less intermediate points our rectangle has. But let's create a second rectangle to, well, kind of get a more complex problem. I convert this one and change the shape to be, well, not symmetric. Maybe like this. And I use a spline mask to combine these two rectangles, or change to A subtract B, to get the second rectangle to be a hole like this. But we still have the same problem actually. It's just not that visible because it's so thin here. We still get these stretch polygons emerging to the outside points. Let's change the width here and we see the problem much better. But this is very problematic for deformations or for further editing after conversion. So let's just see how Xtrudy can change this. And I create an Xtrudy object first of all. And let's start, as we did before, with the original rectangle, so we see what happens there. And you can see also in this problematic case already that evenly distributed and evenly sized polygons are generated. And in the settings, changing the Voronoi radius outline to a high value will result in kind of the lowest triangulation possible. Well, let's just use the spline mask to get the actual result, and we see one difference here, that the rectangle shape is triangulated. I come to this later, but for now let's reverse our rectangle down here, and we see that we get a hole. The reason for that is the spline point sequence direction. The outline is pointing in one direction and holes should be pointing in the other direction. If I change the Voronoi radius here, I can, well, subdivide it even further, avoiding any bad polygons, and we get evenly distributed and evenly shaped triangle sizes. And another key feature is that we can create adaptively sized polygon triangulations for holes and for the outline separately. So this is great if you need more details at the boundaries, for example. And in order to show you what the radius here is really standing for, I'm creating this circle spline, and let's put this up again so it'll be a little faster. And now if I put this here, you can see that the circle is enclosing this polygon star almost exactly. So this is kind of the radius the setting is actually controlling. At least it is the maximum size, depending on the domain that needs to be triangulated. Of course, triangles could be smaller, but it will never get bigger than this. But another key feature that I would like to show you is the refinement. So we know we can have adaptive polygons, lower sized, refined at the boundaries of holes. Or we can reverse the sequence of this spline, and what we get is refinement inside of the area that the hole actually took before. And I have to turn off Xtrudy here because it's slower than the extrude object, that's for sure, but we get more quality. Anyway, let's check out the other settings of Xtrudy object. First of all, the reverse input, which will reverse the input sequences of all the segments of the input spline. Let's make this a hole again. And now check out our extrude settings. We can set an offset along the z-axis in this meshing plane. And let's just create a material so I can show the UV data handling, and putting it on NV Xtrudy as usual. You will see that we get by default a UV flow along the U direction, which is set here in the UV mode. I can of course switch that, but let's just keep that one. I can also flip the U or V coordinates accordingly with these checkboxes. Let's just try this. There you go. So you can already control this in the procedural object. We can also set subdivisions for the extruding part, and we get two new subtabs, profile and remapping. So we can add some beveling to this by controlling the profile of the subdivisions with this custom spline graph. I choose a preset here. You can see it reflects on the bridge polygons accordingly. And now I'm changing the shape of this custom spline graph to be a little more drastic, especially at the boundary. Adding a little more offset, maybe even a bit more, and changing it to our perspective view. Let me turn off this. We can see that at boundaries where our beveling should happen, we only have a few polygons. Well, that's not advantageous. So what we can do is, in the remapping subtab, activate remap distribution, and now we can use this custom spline to relocate our subdivided polygons. So I want more polygons near the boundary. Like this, I can just shift them to the boundary and get a lot more polygons for the beveling. Maybe a little more even. There you go. Now this is much more defined now. And I can do the same for the other side, of course. So this makes it easy to, well, distribute the subdivisions according to your profile spline. Now just keep on tweaking now a little more. So I will play this at a higher speed. So you can see you can create any kind of beveling by using a custom profile. Anyway, now let's put our material back on our Xtrudy object again, and we can see now that our linear gradient, well, has been moving with the polygons distribution actually. And turning off remap distribution will show us how they've been shifted with the polygon. And I can fix this by using remap UV, which will remap the UV data back to the original coordinates. Okay, now let's take a look at the last tab, which is called Selections. First thing I want to show you is Create Vertex Map, which will, well, create a vertex map. While the vertex weights are standing for the adaptiveness of the triangulations. You might also say more refined areas or lower triangle sizes have a high vertex map weighting, and the other bigger ones have lower values. Alright, but we can also create some selection tags for putting materials on this. For the front and the back caps, let me create a material for each. Give this a red color, and well, this one a blue. And now putting it here on the Xtrudy object, and also the other one like this. And now I can just give the name front and back. That's how the selections created by create selection tag front and back are named, and we can see they're applied to them. It's actually quite the same as the native extrude object. And we can also create selection tags for the bridge polygons for the extruded parts. I chose combine, which will create just a single selection tag for all the bridge polygons, and I call it bridge. That's the name of it. You can see, well, it is applied, no change here. If I set it to separate, it will generate a selection tag for each bridge polygon extruded parts. So one here for the outline and one for the hole inside here. What has changed now is that we need a new naming, because we need to kind of identify these parts. So for the outline, it's bridge outline, or in this case, if we have several, bridge outline 0, this is the first segment, and hole, instead of 0, which is wrong now here, we have hole 1. So the outline is always the 0, 1, starting 0 indexed, and holes are starting with a 1. Now I can change this just to give it a different color so you can see it better, like this. So I can separately put materials on the different extruded parts. Also later on, if you have a text spline, for example, you can speak to each single extruded part and give it a different color if you want to. This is just a great variation or extension to the way how the native Cinema 4D extrude object is working, which does not give us this option. And as usual in Cinema 4D, well, the location of the texture tag is important. That's why it will now cover the rest polygons which do not have a material on them. But to really see it, let's just, well, convert our Xtrudy object to a polygon mesh. And here we can see now also the namings of the individual selection tags. The name of the outline bridge polygons is bridge outline 0. So I could also add that name here, which was not necessary, but just to show that it works, like so. Let's go back into our procedural state. We also have select outline vertices and select hole vertices. If I just convert this, we can see that the vertices of the outline are selected, and the same happens for the hole vertices, of course. So for further editing afterward, if you want to convert to a polygon mesh, these might come in handy. Alright, we covered that. Last thing I would like to show you for the settings part is the relax and smooth. Let's turn off the extrude, setting it to 0, so it's just a little speedier. And the smooth and relaxed operations are post operations, and they really help giving some more quality to the triangulation. As you can see here, if I turn it off and on again, you can clearly see the difference. And for the relaxed part, just take a look here. It also helps giving a much better flow of the triangulation. Maximum vertices is controlling the amount of vertices, but you can also see it like an iteration count, because the triangulation is an advancing algorithm. With each iteration, the quality becomes better. Sometimes you also might want to increase this if you have a large domain or a more complex setup, but more iterations also means it takes longer to calculate. And this was it for the settings of the Xtrudy object. Now we come to the refinement tool. Well, I'm starting right away with the default settings, which has the add point mode. So let's click here, and we see a point being added here. This is a refinement point. But let's get rid of this hole first of all. Oh, there's an update issue. I just, well, changed this so it updates again. Not really necessary anymore. Anyway, so back on our Xtrudy object and our edit point, and as you can see, if I remove the smoothing, the point is directly being integrated into the triangulation, and the smoothing will, well, smooth this all out to be better distributed. However, before I show you more, let me just get rid of these materials, and this will also let us see the refinement points much better. Now, if I wanted to move these points, there are two ways. First of all, I can activate this checkbox, move, and click and drag. But I can also do the same by holding down the Shift key, so this also works. At this point, I would like to mention a constraint of the triangulation. Let's move these 2 points with a low refinement rate up here, near the boundary. Well, this will not work actually and give us kind of a false result here, because imagine that at the boundary we have, as we can see here, a big radius. So polygons are quite big there, but we want them to be small there. So this kind of collides, and you have to make sure that this constraint is not broken, you know. So you just have to be aware that you need to move the points kind of outside of this so it can freely adapt the sizes down to the actual refinement, you know. And this happens the same, for example, if you have a very, very big radius at the outside boundary and you want very low radius down there, wouldn't work. Okay, so, but we have now our refinement here. I put another one in the middle, just like this. And now we come to another option, which is the weighting. So you can tell each point how much refinement it should have. Blue means a high radius, and red means a very low radius. Conclusively, you can control the amount of triangles and the size of the triangles by simply tweaking the weighting of the points. Now, in order to show you the next option, first of all, no, I'm not erasing all points. I'm moving some a little up here, and I give this one, well, put it up here and maybe give it a higher weighting, like this. So we have bigger sized polygons there. Now let's switch the mode to add line. And this allows us to, well, add lines of refinement. Click, drag, and now control and click to stop the operation. And you can see that refinement is happening at these line segments that we defined. Let me move this one elsewhere, so the triangulation makes more sense in this area. Move it up like this. Well, not too near to the boundary. You can see that some stuff is happening there. If it is too near to the boundary, I add another line here maybe, because I would also like to show you a different effect like this. You can see also there refinement is happening. And let's erase all the points now here in the erase mode. Like this. And the last one. Okay, so we are left with the lines. And now I want to move this point to the other side. Now see what happens. If I keep it like this, it is triangulated. So the flow is clockwise. If I do it like this, put it on the other side, we get kind of a degenerated effect here, and it gets worse. That's because the flow is now in the other direction, which is a whole direction. So against the flow of the outline. By shift control clicking and then moving, we can just reverse our sequence again, and it becomes the correct refinement. Okay, but let's delete all these refinement points and I would like to show you two more things that are quite important. So I'm deleting this one and going to the settings, set my hole radius bigger again, and let's just create a text spline here. It takes a little while. I changed the text to not FX, Xtrudy. Here we go. I put it into the Xtrudy object, and we can see that it has been triangulated. But we also notice that we only have partly evenly distributed triangles. And this can be problematic, of course. And the reason for that are the intermediate points, which are in the text spline actually set to adaptive. And this can lead to problems. If I lower the Voronoi radius here, you can see that the Y letter has not been triangulated correctly. Because as Xtrudy is trying to have a uniform or regular kind of triangle sizes, and you have been using the adaptive intermediate points, well, you even start with irregular point distributions. So this is getting hard for Xtrudy to resolve actually. So the solution for this is most of the time to use a uniform intermediate points. So we start with evenly distributed outline points, and this makes Xtrudy work much better. As you can see here, we get the correct, uniform distribution as Xtrudy is supposed to do them. And another feature I would like to show you, and for this I changed this material here to have a gradient again, and I put it on Xtrudy. Now let me just, in the text spline, of course, change the intermediate points for speedier results, like this. Also change the gradient a little more to be more exact or drastic, like this. And maybe I change the display mode to constant change so we can exactly see the result of the gradient. And as you can see, it ranges from the left to the right. And now we have this UVs per segment. If I activate it, you can see that UV data is generated for each of the letters, which I always felt was missing in the native Cinema 4D extrude object. So this is this may come in very handy later on when putting real materials on the text spline, and maybe also animating it, because when we have letters that are of different heights, then with the UVs per segment, it will, scale this gradient up more proportionally to the actual size of the letter instead of following a global line, as we can see here. So you see the point of having these UV data separated instead of having them for the whole triangulated domain. Well, this should be it for the introduction of the Xtrudy tool and the refinement tool. In the next few days I will post another video tutorial where I use Xtrudy and its refinement feature to control tearing areas in a closed setup. Well, hope you found that useful, and see you in the next video tutorial. Have fun with Xtrudy, which is now available at fluidsimulation.de. Thanks for watching.